Generative AI. If I had a nickel for every time I heard that word this year. The problem is, in a lot of cases, people don't know what they are talking about. They use the term and they mean something else. In this video, I will explain what generative AI is, when we should use it, the difference between it and other types of AI. Let's go. Imagine this wide area as all AI applications, theories, and literature. This is what is called AI. So AI is the creation of systems that can perform tasks to show human-like intelligence. Well, did you know that AI also include non-human intelligence? We will touch on that towards the end of the video, so stay tuned. Now, within the field of AI, we have this small subset, which is known as generative AI. As the name implies, generative AI focuses on generating new content such as images like Midjourney and DALL-E, text like the famous chatgpt, music, video, and even code by using algorithms and models that have been trained on existing data. Generative AI is the latest and most sophisticated branch of AI. But being powerful and sophisticated doesn't necessarily mean it's the most effective for every task. I mean, consider chainsaw. It's more powerful than a knife, but you wouldn't use chainsaw to cut your steak, would you? Similarly, generative AI may not always be the best choice for every AI application, and we will discuss that shortly. So generative AI produces text. It has that remarkable ability to generate new content in natural language, the language that humans speak. For example, generative AI can produce poetry and code. It always produces stories, summarization, and even translate from language to another. This area of generative AI intersects with another subfield of AI called large language model, or LLM for short. So LLM are models that work with the human languages in general. Now, this is one of the key distinctions between generative and non-generative AI. By the way, non-generative AI is also called discriminative AI. And to illustrate this distinction, LLM can be considered as generative AI when they generate new content, while they are non-generative AI or discriminative AI when they perform sentiment analysis, for example by classifying sentences as positive or negative. I'll cover LLM in details in a separate video, but just to summarize, if a model outputs classifications like labels or even numerical prediction, it falls outside the realm of generative AI because it doesn't generate new content, it just generate labels. Okay, back to the generative AI and let's move to image generation. This exciting development began in 2013 with the introduction of variational autoencoders, VAEs. These models work by compressing input data, such as an image of a cat, into a small representation that captures the essential features of the cat image. VAEs can then decode these features back into new content that resembles the original cat image. Just a year later, Generative Adversarial Network, GANs, entered the scene. GANs consist of two neural networks, a generator and a discriminator, and they work against each other. The generator creates fake data, such as new image, meant to resemble real data, like an image of a cat. The discriminator then receives both real and fake data and aims to distinguish between them. During the training, the generator attempts to create data that can fool the discriminator into perceiving it as real, while the discriminator strives to better distinguish between real and fake data. These two components are trained together through a process called adversarial training, and there are more advanced methods to generate images, but I want to describe these two because they were the start of image generative AI. So what about the rest of this area? Well, the advancement of generative AI can be attributed to another subfield of AI called deep learning. And deep learning is, in simple terms, refers to the use of large artificial neural networks that are capable of finding complex patterns. And it's important to understand that deep learning is broader than generative AI, but narrower than AI as a whole. One type of deep learning called convolution neural network, it can analyze images, detect faces, classify objects, and so on. And it's also to remember that image classification falls under discriminative AI, not generative AI, as it doesn't create new content here, it just classify images or detect objects. Now for the completion of the context, let's draw another boundary here, denote what it's called as machine learning. So machine learning it's a branch that focuses on creating algorithms that learn from data. It also predicts and classify like the deep learning, but it's much simpler. So even though both machine learning and deep learning can classify and predict, deep learning is more powerful when it comes to unstructured data, while machine learning is bounded by tabular data or pretty much structured data. So instead of inputting a picture of a cat, we can input a table that lays the attribute of a cat. So for example, does it have whiskers or pointy ears or fur and so on. Some examples of machine learning algorithm includes decision tree, which we covered in one of the previous videos, random forest, support vector machine, k-means, KNN, and so on. Now we come to this area where all the rest of AI tools. Remember when I mentioned that AI is not mimicking a human intelligence only, but non-human intelligence as well? I was talking about the rest of AI tools that I personally think they are underrated in data science curriculum. These sets of tools are genetic algorithm, swarm intelligence, and colony optimization, and Bayes algorithm. That's it. Now you can distinguish generative AI from non-generative AI and has a better understanding of the AI algorithms spectrum. If you want to see more of this content, please like, share, and subscribe.